This is Professor Antonio S. Marahas, and this is Advanced Digital Technique. Okay, so we go now to 4-variable map. Okay, so the first rule, 8 adjacent cells yields a single variable. Rule number 2, 4 adjacent cells yields a 2-variable term. Rule number 3, 2 adjacent cells yields a 3-variable term. And 4, a single cell which cannot be combined yields a 4-variable term. So we have here a truth table again. The table was taken based on a particular problem. So later on, we will have a sample problem. So, how many cells do we need in order to satisfy a 4-variable map? So, you have 2 to the 4 is equal to 16. So, we need 16 cells. Okay? So, we draw the map. And we need 16 cells. Okay, so that will be our map equivalent. Okay, then all we have to do now is to determine the value here of your cells. So you have A, B. You have, let's say, we obtain the, we call it the product term of the map. So you have A is 0, B is 0, C is 0, and D is 0. So you have A bar, B bar, C bar, D bar. Then you have here A bar, B, C bar, D bar. Then you have A, B, C bar, D bar. A, B bar, C bar, D bar. Then you have A bar, B bar, C bar, D. And then you have A bar, B, C bar, D. Then you have A, B, C bar, D. Then you have A, B bar, C bar, D. And then you have A bar, B bar. Then you have C, D. Then you have A bar, B, C, D. Then you have A, B, C, D. Then you have A, B bar, C, D. And then here you have A bar, B bar, C, D bar. Then you have A bar, B, C, D bar. And then you have A, B, C, D bar. Then A, B bar, C, D bar. Okay? So this will be our product or sum of product expression or map equivalent. Okay? So, if you notice that in this particular cells, these 8 cells here, the common is A bar. So this belongs to A bar. The 8 cells belongs to A bar. And this one here, another 8 cells, the common is A, so this belongs to A. And then for B, this cells here at the middle, 8 cells, the common is B. Okay, and then on this side, B bar. Then here, the common here is C bar. And then here, the common is C. Okay? Then here, the middle, the side middle, the common here is D. Okay? So therefore, here you have D bar and D bar. Okay? So this one here belongs to B bar, and these 8 adjacent cells are adjacent together. Again, if you fold it, this part here and this part here will come together and they form as an adjacent cells. Now, this part here and this part here are also under D bar, and they are also adjacent, because again, when you fold it going up, this part here and this part here will go together, and therefore these 4 cells here and these 4 cells here becomes adjacent. Okay? Now, let us find the simplified logical circuit of our table using, of course, the 4 variable map. We know that this one here is A, B, C, D. The values are 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And this one here belongs to A bar. This 8 cells belongs to A. This 8 cells belongs to B, B bar, and B bar. This one here belongs to C. This one here belongs to C bar. And this one here for D, D bar, and D bar. Okay? Then we locate the value of your X into our map. So you have 0, 0, 0, 0, you have the output is 1. So 0, 0, 0, 0, the output is 1. 0, 0, 0, 1, 0, 0, 0, 1, the output is 1. Then 0, 1, 0, 0, 0, 1, 0, 0, the output is 1. Then 0, 1, 0, 1, 0, 1, 0, 1, the output is 1. And then 0, 1, 1, 0, 0, 1, 1, 0, the output is 1. And then you have 1, 0, 0, 1. You have 1, 0, 0, 1. So the output here is 1. And then 1, 0, 1, 0. So you have here 1, 0, 1, 0. The output is 1. Then you have 1, 1, 0, 0. 1, 1, 0, 0. The output here is 1. Then you have 1, 1, 0, 1. 1, 1, 0, 1. Then 1, 1, 1, 0. 1, 1, 1, 0. And then the last one is 1, 1, 1, 1. 1, 1, 1, 1. So the output there is 1. So again, the grouping will be 16, 8, 4, 2, 1. Okay? So if all of the cells are, if all 16 cells are 1, then that means that X will be equal to 1. Okay? So next is 8 adjacent cells. So wala 16. So we go to 8 adjacent cells. So do we have 8 adjacent cells here? I think there is none, no? Wala po siya 15 adjacent, 14, 13, 12, 11, 10, 9. So only 16, then you go to 8 adjacent cells. Okay? So wala po siya 7 and 6 and 5 adjacent cells. So again, you go to 4. So you have 16, 8, 4, then like 3, 2, and then 1. So there is no 16 adjacent cells. There is no 8 adjacent cells. So we go to 4 adjacent cells. Okay? So what are the adjacent cells here? So this one here is adjacent. Okay? Then, instead of having this one, we go straight. Going here, these are 4 adjacent cells. Okay? And then, this one here, if you notice, is not yet grouped. And this cell here is adjacent to these cells. So we make use of these cells here for the grouping of this particular cell. So that will be our grouping. Okay, and then is there any other 4 adjacent cells? This cell here is not yet group, which is adjacent to the cell and adjacent to these 2 cells here. Okay, so you still have 4 adjacent cells since this one here is not yet grouped, like that. Okay, and then this cell here, the remaining cell, is adjacent to the cell. So no more 4 adjacent cells, so we go to 2. This cell here is adjacent to this one, so we group them as one group. So that will be our grouping. Okay, so what will be our equation? So for this particular group, 4 adjacent cells, this one here and this one, this belongs to what? This is under D. Okay, and then under D bar. Okay, it's under D bar. Okay, so it says here 4 adjacent cells yields a 2 variable term. Okay, that is under B, this one here, and this one is under B, and at the same time it is under D bar, the intersection of B and D bar. How about this one? Okay, this line, 4 adjacent cells in line. So this belongs to, again, this belongs to B bar, B I mean, and then at the same time belongs to A. Okay, or you can say A, B. And then this one here, this line, this belongs to C bar. At the same time belongs to D. Okay, how about this one? The square. This belongs to A bar. And at the same time belongs to C bar. Okay? And then this one here, you have 2 adjacent cells yields a 3 variable term. So you have A, C, and D bar. That is the intersection. This group has is under A, C, and D bar. The intersection of this particular cell is A, C, and D bar. So how many groups do we have? 1, 2, 3, 4, 5. So you have 1, 2, 3, 4, 5 equations. Then we put them together using the sum of product expression. So our equation will be A bar, C bar. Again, this can be in any order. Then you have B, D bar. Then you have AB plus C bar D plus ACD is equal to X. Okay? That will be our simplified logical equation that represents this particular output X. Okay? So if we will draw the logical circuit equivalent, we have 1, 2, 3, 4, 5, and gates. Okay, so let me erase first this area here. Okay, so we draw the logical circuit of this equation. 1, 2, 3, 4, 5, and gates. We have 1, 2, 3, 4, 5, and gates. So you have inputs A bar, C bar. Then you have B, D bar. Then A, B. Then you have C bar, D. Then you have A, C, D. A, C, D bar, I mean. So A, C, D bar. So these AND gates are being ORed together. So you have here an OR gate. So even if you have many inputs here in this particular area, try to make the symbol here for the OR gate as much as possible as big as the AND gate. So if you have many inputs, all you have to do is to extend the input part of your OR gate. Okay, so this will be our logical circuit equivalent, and this will be your X. Okay, so that is our simplified logical circuit. Okay, so let's have more examples on a 4-variable map. Okay, so we have here, draw the simplified logical circuit for the following equation. So this is for number 1. This is our logical equation. And we want to use K-map to simplify this logical equation so that we can arrive with a simplified logical circuit. So the first step again is to make a map. Okay, 16 cells. Okay, so the inputs are A, B, C, D. The values of your variables are 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And we know that this belongs to A bar. This area here belongs to A. This belongs to B. And this one here is B bar and B bar. Then you have C, C bar. And then you have D, D bar, D bar. Okay? Then we locate these equations into our map. So, we have A, B, C, that is 3 variable term equivalent to 2 adjacent cells. So, where can we locate A, B, C into our map? So, you have A, these 8 cells. Then B, it is in these 4 cells. And then C, where C? These 2 cells here. So, that is the intersection of A, B, C is A, B, and C. These 2 adjacent cells. So you place 2 ones there. And then you have A, B, C bar D. That is a 4 variable term that is equivalent to 1 adjacent cell. Where is it located? So you have here A, and then B, and then C bar, and then D. That one. So it is located there. And then B bar, that is a two-variable term, represents 4 adjacent cells. So where is it located? So you have B bar here, and then at the same time D bar. Where's that? That one. So B bar, D bar. That will be this particular cells. In other words, these 4 cells here are adjacent. Ano man? Because again, if we fold this one there, mag-abot na yung apart, o kani, and then we fold this one here, going there, 4 of these cells now will be connected together, and they are adjacent, no? So, more or less, murag gawa siya na 4 adjacent cells in square, okay? And then, we have A. Where's A? This one. 8 adjacent cells. So, some of the cells have already a value of 1. So, we just put 1 on the blank cells. This is under A. Okay? Then we have B bar, C bar, D bar. That is a 3-variable term, which means you have 2 adjacent cells. So, you have B bar here, 8 cells. And then C bar here, so that means that these 2 cells, 4 cells here, and then D bar, where's D bar? This one. Okay, so we have already 1 here and 1 here, so no need to place another 1. Then we have A bar, B, C, D. That is 4 variable term. That means that 1 cell. So you have A bar, B, C, D. 1. So you put a 1 here. And then you have A, D bar. That is 4 adjacent cells. A, and then D bar. Where's D bar? This one. So you have this one and this one. So you have already a 1 in that particular location. So we have already represented our equation in our map. So the next step is for you to group the cells which are adjacent together. Again, what is the grouping? 16, 8, 4, 2, 1. Okay? So there's no 16 adjacent cells here. So we go to 8 adjacent cells. So we have here 8 adjacent cells. This one. Okay? There. We have 8 adjacent cells. And then next is 4. There's no more 8, so we go to 4. 4 adjacent cells. Which one is adjacent? This one here and this one is not yet grouped. So this cell here and these cells here are adjacent together. Now, as I've said, why are they adjacent? When you fold this there, these 2 part here, this one and this one are adjacent, and then once you fold it there, this 4 here becomes adjacent. Okay, so that will be our grouping. These 4 adjacent cells are, these 4 cells are adjacent. Okay? Then, no need to group this one because they are already grouped into one adjacent cell. Because once you group this again, it becomes a redundant variable. Okay, next is, wala na 4, we go to 2 adjacent cells. So this one here, the remaining one here which is not yet combined, we find a particular cell which is adjacent to this particular cell, and that is this one. Okay, so we group this one and this one as one cell, one group I mean. Okay, so everything is already grouped. Then we obtain the logical circuit equivalent. So for this 8 adjacent cells. This belongs to A. And these 4 adjacent cells, this one, belongs to B bar, and at the same time belongs to D bar. Okay? And this group here belongs to B, at the same time belongs to C and D. So that will be our equation. So we just use the sum of product expression. What will be our final equation? So we have B bar, D bar, plus A plus B, C, D is equal to X. Okay? And so the logical circuit equivalent, simplified logical circuit equivalent will be, you have here an AND gate, B bar, D bar, then you have B, C, D, okay, and these two are being ORed to A. So you have here A. So the output is X. That will be our logical, simplified logical circuit. Another example is this particular equation. So we want to determine the simplified logical equation of this particular equation and then draw its simplified logical circuit. So again, we make a map equivalent. Okay, so then we locate the equation into our map. Okay, so we have A, C bar D, that is a 3-variable term that represents a 2 adjacent cells. So you have A here, so you have A, then C bar, that is this one here, so you have 4 cells, and then D, that is this one. So you have 2 adjacent cells. That is A, C bar, D. Okay? The next is 2 variable terms, B bar, C bar. So where is B bar? Here, that is B bar. And then C bar, that is this one. Okay? So B bar, C bar. That will be this particular 4 adjacent cells. So you put one here and then another one here. So kana na naman na siya. So no need to put another one. Then you have 3 variable terms, 2 adjacent cells again. So you have A bar, this one, A bar, B bar. So gani upat na lang. And then D bar. Where's that? This one and this one. So na naman na siya. So you put a 1 there. And then you have A bar, C bar. You have A bar and then C bar. This one, these 4 adjacent cells. So na naman duha, so you put 2 here. And then A, B, C. You have A, B, C. So you put 2 ones in each cell. And then you have B, C bar. You have B, C bar. Where's that? This one. So you have B, C bar. So these 4 adjacent cells. So just put 1 there. And then you have A, B, C, D. A, B, C, D. Okay, so this one. And then you have A bar, B bar. A bar, B bar. So these 4 adjacent cells in line. That will be your location of this particular equation. The next is, again, you group these cells here. What will be, again, the grouping? 16, 8, 4, 2, and 1. So, since na bakante diri, so we cannot say that there is 16 adjacent cells. Now, we go to 8 adjacent cells. Where are the 8 adjacent cells? This one here is 8 adjacent cells. So, you group them as 1. Okay? Then, you find another 8 adjacent cells. Na pa ba? I think wala na. So, we go to 4 adjacent cells. Where are the 4 adjacent cells? These 2 cells here are not yet grouped. And these 2 cells here is adjacent to these 2 cells here. So, we can group them as 1. That is 4 adjacent cells in line. Okay? And then, another 2 cells here, which is adjacent to these 2 cells here. So, again, we have another 4 adjacent cells. Okay? Now, since all of the cells are already grouped, then we obtain its logical circuit equivalent. Now, for this one here, this belongs to C bar, right? So, 8 adjacent cells combines to yield a single variable term. And this one here belongs to what area? It is under A bar, at the same time B bar. So this one here is A bar, B bar. Okay? How about this one? This one here belongs to A, at the same time belongs to B. Okay? So that the final equation will be C bar plus AB plus A bar B bar is equal to X. Again, pwede ma-interchange ang iyahang location sa imuhang variable terms. So this will now be the simplified logical equation. If we will draw the simplified logical circuit as required, this will be your simplified logical circuit. We have 1, 2 AND gates. Then, you have A, B, and then you have A bar, and then you have B bar. And then this 2 AND gate is being ORed to C complement. Then we have C complement, no? So there is a bubble here. Okay, so that is your C, and this will be your X. Okay, so if you want to draw the logical circuit in the experiment type, all you have to do is to connect all the A's here, the same variables, and then you have here B, and then of course another input which is C. So you have A, B, and C. This is for experiment purposes, the logical circuit equivalent. Okay, so that will be our simplified logical circuit.